In order to find the distance between 2 points, we use what's called the distance formula. We have to plug in the numbers from the point where our line starts and stops. Remember, each point has an x number and then a y number in the parentheses. So in the point 1, 2, 1 is the x number and 2 is the y number. And in the point 5, 5, the first 5 is the x number and the second 5 is the y number. We use little ones and twos to keep track of which ones are from the first point and which numbers are from the second point. In order to find the distance between 1, 2 and 5, 5, we need to plug those numbers into the distance formula and then use the order of operations to simplify. First, we would do the subtraction inside of the parentheses. 5 minus 2 is 3, and 5 minus 1 is 4. Then we would do the exponents. 3 squared is 9, and 4 squared is 16. Then we would add 9 plus 16 is 25. And very last, we would square root 25. On a calculator, we can plug that in and see it equals 5. Remember, a square root finds what number we would square to get 25, or what number we would times to itself to get 25. In this way, we found that the distance between the first point and the second point is 5 units. Now, these numbers that we used in the distance formula are exactly the same that we use in the slope formula when we are trying to find the slope by subtracting the y numbers and x numbers, getting our slope of 3/4, because from one point to the next we go up 3 and over 4, and slope is also known as rise over run. Now let's look at what happens when we find the distance and we don't get a perfect whole number. Sometimes when you square root, it's an irrational number, a never-ending decimal. We don't want to round it, so we need to know how to find the exact answer. So here's another example. If we want to find the distance from the point -1, 5 to the point 5, 1, we would first plug those numbers into the distance formula, remembering that the first number in the point is always x, and the second number in the point is always y. So when we plug these numbers into the formula, we get the distance is equal to 5 minus 1 and 1 minus -5 inside that formula. We use the order of operations to first subtract inside the parentheses, then square those numbers. Remember, a negative number squared should always be positive, since a negative times a negative is positive. Don't forget the parentheses in your calculator. Then we add those two together and we get a square root of 52. If we use our calculator, we can see that that's a never-ending decimal. We don't want to round it, we want to know the exact answer, which means we're going to have to simplify this radical, square root of 52, using a factor tree. I'm going to show you how that's done. We take the number inside of the radical, or square root sign, 52, and we split it up into its factors. We know that 2 has to go into 52 because it's an even number. And we break that up. 2 times 26 is 52. 26 can also be broken up into 2 times 13. But 13 is a prime number, and 2 is a prime number, so we can't break this up any farther. That means we found that the square root of 52 is the same thing as the square root of 2 times 13, since those are the factors we get when we break up the number 52. What we want to look for are two factors that are the same, because if we square root a number times itself, that would just equal the number. So the square root of 2 times 2, which remember that's the square root of 4, is equal to 2. Anytime you have two identical factors inside of the square root, we can pull that factor out and put it in front. So the square root of 52 is equal to 2 times the square root of 13. This is the exact answer in its simplified form. There's just one more thing we're going to look at. As we talk about distance and we talk about slope, you'll be asked about parallel and perpendicular lines. Parallel lines are simply two lines that have the same slope. So if we looked at the equation y equals 3/4 x plus 4, a line parallel to that equation would have to have the same slope, which would be 3/4. Remember, the slope is always the number in front of the x in slope-intercept form. Perpendicular lines are the opposite. Perpendicular lines have to have opposite reciprocal slopes, which means you would take the slope, you would flip it, and change the sign. So if we use that same equation, y equals 3/4 x plus 4, and we find a line perpendicular to it, it must have a slope of -4/3. Here's how I found that. We look at the slope, which is the number in front of the x. First, we take 3/4 and flip it, so it becomes 4/3. Then we change the sign. Since it was positive, we would change it to a negative number. So -4/3 is the opposite reciprocal, and a perpendicular line would have to have that slope.